In the first part of the lecture, I made it sound as if the outputs from our scripts were really tidy and neat and nice, beautiful graphics. But in reality, our working directory for the course is a bit of a mess, right? We have all the original Callisto outputs and the log files. We have some text files. We have our R project file itself, maybe some extra R scripts that I was working with. And we have, if you ran clust, we have output folders for that, maybe some figures that you exported, all your scripts, a study design. And this is for a relatively simple data set, right? A data set that only has 10 samples and 2 groups. You can imagine what this working directory would look like for something like the Schisto data set, which had many different groups and comparisons and would warrant sort of different kinds of analyses and many different kinds of graphics. So the working directory itself is not as nice and clean as what I portrayed here. And so we have to figure out how to sort of Hansel and Gretel our analysis, right? How to leave a trail that someone else could follow as we move through any workflow, right? That kind of stitches together all of our outputs, but also the inputs, right? What was the table that was used to generate that heat map? And so what we'd like then is to take our working directory that includes our R scripts, figures, tables, text, and more, and put that into a document. And many of you did this in the Hack Challenge, basically putting together the figures in like a Word document, but it becomes more complicated when we think about how to do that where our figures are attached to our code so that people understand what piece of code generated that figure, table, or text. All right, so, and ideally what we'd like is a document that's dynamic, meaning that if I change any of the code or script in that document, it will regenerate the figures themselves and put them back into the document. So imagine if I change what I decide are my logfold change or p-value cutoffs for decide tests, I don't want to have to go back and regenerate all this stuff and remake my document in Word. That would be horrible. I want to just change one line of code in my document and recompile it so that the instructions are used to recreate the figures themselves and recreate the document. All right, so that's the goal for today, and that's what we're going to do with R Markdown. Before we jump into R Markdown, you have to understand a little bit about the underlying premise and how it's different than the way we are used to compiling documents, which is for, I think, most of us using Microsoft Word. Microsoft Word falls into a category of word processing tools that are called WYSIWYG. WYSIWYG. What you see is what you get. And that's because the way you work in Microsoft Word is you directly change what you want things to look like on your layout. And what happens under the hood is that movement of your cursor or that clicking of a button to change something to bold or italics then is sending instructions to Microsoft Word to then change that formatting. So what you see is ultimately what you get. That has certain disadvantages associated with it, and many of you can relate to this. This is one of my grant proposals, and this is me just dragging around a figure, and all that text is trying to move around. Other figures are jumping around as I do that, and that's because Word is struggling to try to figure out, how to give me what I want based on what I'm dragging around, okay? And this gets even worse as documents get larger and more complex. And so writing, not that I've written a book, but writing a book in Microsoft Word can be a challenge, right? With all the different chapters, if you have a lot of figures or graphics, even just writing a substantial grant with many figures and text boxes below those figures creates somewhat of a challenge, right? And so that's where you run up against the limitations of this kind of what you see is what you get approach to compiling a document. So that's where markup languages come in. And they offer another way to compile a document and a way that becomes really powerful for us in R. So what is a markup language? Well, the best way to describe it is it's a system for annotating a document in a way that is syntactically, so syntax, distinguishable from the text of the document itself. So really, markup languages are formatting syntax. So let's think of them as the kind of formatting syntax we might edit by hand a document with, where you say, oh, you need to insert a word here, or you need to remove or close a space, or add a space, or start a paragraph, etc. So this is not WYSIWYG. This is not what you see is what you get. This is what you see is what you want. You're articulating in a way that's syntactically distinct from the text itself. You're indicating what you want. Okay? All right. So a markup language, I said it's a system for annotating a document in a way that's syntactically distinguishable from the text. A few of these you're familiar with. HTML is a markup language. XML, which you may not have encountered as often or at all, markup, and wiki pages. And I don't mean Wikipedia. Wikipedia is based on wiki, but the idea of editing a document that appears on a website, wiki are markup languages as well. We're not going to use any of these. We're going to use a separate markup language that's confusingly called Markdown. So Markdown is a type of markup. Okay. The point, though, is that this what you see is what you want is a really effective, simple way to control the way a document finally appears. So for example, this is markup syntax on the left-hand side, and what that syntax will result in on the right-hand side. So if I want a level 1 header, I can put a pound sign in front, and it'll make it big and bold. And I can control that, making level 2, 3, 4, etc., each of these making a smaller header. I can make italics by putting an asterisk at each end of a word, or an underscore at each end of the word. And I can make bold by putting 2 asterisks or 2 underscores to give me this. Superscript is easy to indicate with 2 upper carets here to make something superscript, or strike through, or any number of simple ways to kind of structure a document. This becomes really not just useful, but essential for rendering complex documents. And that's key to understand, is that Markdown can render complex documents that simply aren't possible within Word. An example is musical notes, or music language here. So easy to structure in a clear syntax way, and can be then compiled by something that can recognize Markdown to produce the final document. Same thing for mathematical formulas. If you've ever tried to put a mathematical formula in line in a document, it can cause real headaches because of numerators, denominators, lots of superscripts and subscripts, and special characters. But that's actually really easy to control in Markdown. So, where can we find uses of Markdown? Well, one is in the course website itself. So it turns out every one of the lecture pages that you've been looking at throughout the course are just text files that use markup. So a few things we can highlight here, and that text file leads to this final page that you actually have been interacting with on the website. And there's a few obvious examples of markup here. One are these level 2 headers, which gave us this. We also have a single asterisk, not one at each end of a word or phrase, but a single asterisk leads to bullet points. We can see a number of places where I've bracketed a word and immediately followed those brackets with parentheses and a link. And that's actually how you set hyperlinks. So now those are all clickable, and clicking on human takes you to this link. Clicking on mouse takes you to this other Dropbox link. And you can see other examples of where I've made things italics here, or bold, right? All the links I made bold just to make them stand out more. You can even use the forward tick. 3 of them on each side of a word will make it look, will indicate its code, and gives it a sort of code look to it. So how do we do Markdown in R? We're going to be writing and compiling the R Markdown document we'll use in class using RStudio and Knitr. And knitr is really critical because it's actually the tool working under the hood to take all of the code and the outputs from the code, those building blocks I told you about, and it's going to knit those together, thus the name, into a final PDF or HTML document. So the way this whole process starts is just by clicking on the new document in the upper left of RStudio and choosing R Markdown. And what you'll end up with is a simple document that has 3 elements, actually really 2 elements to start. You'll end up with a header at the top of the document, and that's called a YAML header, yet another markup language, YAML. And it's some special formatting at the top of the document that provides instructions when that document gets compiled about what should be produced and how, and any special formatting instructions like a header or a footer, page numbers, that kind of thing. So it kind of outlines some of the key instructions. It's not shown in your final document. Again, it's just instructions for how that document should be compiled. Obviously, the other key element of an R Markdown document is the code. We're going to work with these code chunks. You've already been working with the concept of a code chunk throughout the course, but now you're going to see how it relates to an R Markdown document. And then lastly, you have to put in your own words, right? So a key part of any R Markdown document is not just the code and the outputs that that code produces, but your description of what you're doing and why. So a good R Markdown document should not just show how you did the analysis, but it should also explain the results and why you did the analysis. You can think of this as your electronic lab notebook. So this is what it looks like when you've started a new R Markdown document. If you clicked on New and chose R Markdown, this is the YAML header. In this case, it's very simple. We'll work with a more complicated YAML header to produce the document we'll use in this course. But this YAML header has just the title, and that the document should be compiled to be a web page, an HTML document viewable in a browser. We really have 2 key options that I think are most useful: compiling it as an HTML that you could double click and open in a web browser, or compiling it as a PDF document. Both are useful for different situations. The PDF document obviously is most useful for including in a manuscript as a supplementary file. You can see the YAML header is indicated by these 3 dashes. The start and stop of the YAML header is here. And again, this header will not show in the final HTML document once this is compiled. We also have a code chunk, and code chunks are demarcated by 3 forward ticks and closed with 3 more forward ticks. After the first 3 forward ticks, there's some curly brackets here that set up the instructions for how that code chunk should be run and evaluated. We're going to talk in more detail about setting that up in just a minute. But these code chunks can have different sorts of languages in them. So the first indication, or the first argument, if you will, in these curly brackets is what language the code in that code chunk is. So we're obviously going to be using R. So you do a lowercase r, but you could also say that you don't want an R code chunk, but you want a Bash code chunk or a Python code chunk. So that's an important thing to understand here, is that RStudio and knitr can recognize different kinds of coding languages inside of the same R Markdown document. How would that apply in our case? Well, we could easily run the clust program, the command line program in Bash directly in our Markdown document, and we could potentially do the alignments even. So we could start from scratch with raw data and use Callisto, command line tool, directly within the R Markdown document. And then lastly, I told you you have your own language, right? And this is that idea of Markdown, where we have a level 2 header, we have a link, we have a bolded word. So you can use that Markdown syntax to start to write about what you've done or will do in the next code chunk. Okay. We've already been operating with this habit of writing our code and organizing it in these chunks, and it's for this very reason. It makes it easier for us now to think about how we make this transition from an R script to an R Markdown script. So any of these could be adapted, any of these code chunks could be adapted to an R Markdown code chunk, but we're going to focus on using the essentials since that strips away a lot of the didactic, demonstrative code that we used and really just uses the code that we need to make the different objects or graphics for the course. So, but in general, any of these could be used to make an R Markdown code chunk. So I told you the code chunk starts with these 3 tick marks and ends. That marks the end of the code chunk is 3 more of them. And you have curly brackets with the letter R. That's the minimal R Markdown code chunk, this, all right? Your code then goes here. There's additional sorts of arguments or information you can put and should put in the curly brackets, but this is sufficient to make an R Markdown code chunk that would be run. What language are you using and what's the code that should be run? You should also name your code chunks, and that's any name can go right after the R, just a space separating it. And it can be more than one word that's the name, but it's interpreted as the name because it's separated from the R by 1 space, not a comma. And then after the name, you have a comma and you have additional arguments that we'll talk about in just a minute. Like, for example, this code chunk does not have a name. We don't have anything after the R. But we have that we do not want messages displayed and we do not want warnings displayed. Why? Well, when we've been working in R Studio up to this point, anytime we ran something, even loading a package like the tidyverse, we often received messages or warnings in the console. And that's fine in the context of working in R Studio in the way that we were, because it's useful to see those messages and useful to see those warnings. However, now anything that's generated by this code chunk will appear in the final document that we make, whether it's an HTML document or a PDF file. And so in that case, having a message displayed or having a warning displayed is actually not useful, right? That's a lot of text potentially that would be then printed into our final document that's compiled. So it's very common to set messages and warnings to be false. So you can customize these code chunks using arguments just like you've been doing for different functions throughout the course. A good rule is that one R Markdown code chunk should produce 1 output, a figure, a table, etc. If in the case of our essential code chunks, we had 2 different things being made, maybe a table and a figure, then we would want to split that code chunk into 2 R Markdown code chunks so that each one generated only a single output. All right, how do we get the most polished R Markdown document possible? Well, one is we can take advantage of all these code chunk options. I talked about, messages and warnings and making those set to false, but there's other things like an echo option, which takes a logical, true or false, echo equals true or false, that determines whether the code is shown in the compiled document. So you can imagine there's probably examples of code that may not be useful to show in the final document, and so you can just have maybe the code is needed for the document, the analysis to actually run properly and produce the final document, but it's not code you want to show. So in that case, echo simply hides that code. It's still run, but it's hidden it's not printed into the final document. Similar to that, the eval option, again, eval equals true or false, determines whether the code is run. So it's kind of the opposite of this. So now you can have code that maybe you want to show them was used to do your alignments, but you're not actually doing the alignments, so you don't want this run. So you could have code that's shown and not run, run and not shown, or not shown and not run. The cache option, again, a logical true-false, lets you state whether the result, the output from a given code chunk should be cached so that you don't need to run that code chunk again if you recompile the document. It will just go and get the output and put it into the final compiled document if you try to run it again. You should always name your code chunk. It's just going to be easier to track where in the R Markdown file an error is coming from if you've given it the code chunk an informative name. It also makes navigating around the document easier, and we'll show examples of this. And each code chunk must have a unique name. If you name one code chunk heat map and the code chunk below it heat map again, because maybe you're making two heat maps, that will throw an error. So you would need to name the first code chunk heat map and the second one heat map 2. And then lastly, we always end with a code chunk. I think it's useful to end with a code chunk that just has a single function with no arguments inside the code chunk that is session info, capital I, open and close parentheses. This is from the DevTools package, and this will cause the output from running this will print out in the final document, and it will show everything about your session, the version of R, version of RStudio, which packages were loaded, and their versions. It's a great way to document exactly sort of the software environment that you use to run this analysis that's shown in the final compiled document. I will say it doesn't actually, none of this that we're talking about today actually provides readers of that document with the code, with the software. And that's a challenge, and it's one we'll address in the next lecture, which is how do we maximize reproducibility by creating a situation where users have not only the code and the outputs, so transparency and reproducibility, but actually have the raw data and the software environment so that they can run your entire analysis again. So session info is at least a first step towards showing them what software environment you had. And then we won't talk about this, but you can add references really easily using init citations. And we will talk about how to use inline code that's not contained within a code chunk, but is still recognized by the compiler and evaluated. All right, and this is a great way to avoid manual errors, and I'll explain, it'll be more clear why that is when we actually see inline code in our document. All right, how do we use this in my own lab? You can look to several of our recent papers. This one that was a collaboration between our lab and Phil Scott's lab. It's the one that your data's from. It's Camilla's paper. If you take a look at supplementary file 2, it's a supplementary code file that is the PDF that was compiled from our R Markdown document, right? And you'll see how to set up a table of contents like this. And this is a clickable table of contents in the PDF that takes you to the code that generated figure 2b. And it shows figure 2b, right? Knitter put together the code with the output. All right, so the reader of this Markdown document, of this compiled document, can see exactly how we sort of moved in an organized way through really the steps of the class, right? Move through these different parts of an analysis to produce figures, and they can see those code and the figures by clicking here. They can also see how we then went on and did different kinds of analyses, even of published data. All right, we see this again for collaborations, even when we're not the primary lab or group working on the project. If we work or collaborate with another group and we're doing some analysis with them, again, supplementary code file, okay? All right, so now in the next video, we'll actually move over to RStudio and start the R Markdown demonstration.